You're very talented. All right. So here's an antiderivative that actually is going to be very hard to do given the strategies that we know. Like, given the fact that it's a product, really our only hope is what? Yeah, one's the chain of the other. And I certainly don't think x plus 7 to the 10th is going to be the chain of x. And I know that x actually isn't going to be the chain of x plus 7, right? Because they're the same degree, and that's a problem. I have something that's going to help us out, all right? And really what it is, it's a change of perspective. And the change of perspective requires something called substitution. And we're going to make a substitution at the beginning. We're going to solve an easier but related problem. And then we're going to substitute back at the end. You ready? Okay. So many books call it U substitution, so we're going to use a U. You don't have to use U, but you can. The solution guide actually uses U or W substitution for all the problems we've been doing so far, which actually makes the solution guide a little confusing. They use a strategy that's harder than you need to recognize the chain. But the reason they do it is because when you do U substitution that we're going to do right now, you already know it. I found over 10 years that it's actually okay just to wait to do U substitution until you need it. Okay. If you really like this, though, and you want to go back and do it the way the solution guide or the book does it, you can go back and do everything that we've done so far using U or W substitution. Okay, so the key to using U substitution is you find the more complicated expression and you pick the inner function. So in this case, we have x and we have x plus 7 to the 10th, the more complicated one. X plus 7 to the 10th, and I pick the inner function and I let u equal x plus 7. And that first key step is going to unravel other relationships, which is just going to allow me to change this problem into one that I can solve. And this is going to be number 10 on the gateway. Okay, so if you can look at the steps, see the strategy, and be okay with it, you're going to get number 10 right. Okay, and we'll do a few of them. So I'm going to let u equal x plus 7. This leads me to the relationship that means x must be equal to u minus 7. Right? Now, if u was 0, x would be 7, but right now. If u equals x plus 7, x must equal u minus 7, right? So just subtract 7 from both sides. There's one more relationship that I'm sort of interested in, and that's looking right here. If I asked you for u prime, it'd be 1. Now, I'm going to write that as Leibniz notation. du dx equals 1. And that means that du equals dx. Is that all right? In this case, it's very straightforward because the derivative of u equals 1, so du equals dx. In some cases, it's not going to be equal to 1, so there's going to be a relationship between du and dx that's not a 1-to-1 ratio. But for now, start off with that, and we're ready to plug some things in. So this problem is the same as, instead of x, u minus 7. And instead of x plus 7, u to the 10th. And instead of dx, du. So I've turned everything that was in x's, in terms of x's, into u's. All right? And now I can do this problem. Because what I can do now is I can now distribute and get u to the 11th minus 7 u to the 10th du. And before I couldn't distribute, right? I couldn't distribute an x into the x plus 7 quantity to the 10th. But because I switched my perspective in terms of u's, I can now distribute. And now this problem I can do. The antiderivative of u to the 11th, 1/12 u to the 12th. The antiderivative of 7u to the 10th. Come on, everyone says. And then, don't stop there. Plus c. And we're almost finished. Exactly. All right, so our answer is in terms of u, but Gabby's saying the question was asked in terms of x. So I have to do exactly what Gabby said. Instead of u, I have to put in x plus 7. Whoops. Oh my goodness. And that's the answer. Gesundheit. Gesundheit. Let's see. I'm trying to think. X plus 7 minus 7. All right. Hold on. I'm not sure if it's going to work. That's why I'm a little cautious. I thought you were making fun of me because I was. No, you're not. All right. So humor me for a second. If I take the derivative of this, right, I should get this. All right. So let's try it. I get x plus 7 to the 11th, right, minus 7 times x plus 7 to the 10th. I don't think so. Right? All right, so I could factor out what's common in both this and this. X plus 7 to the 10th, and I'd be left with, in the first term, x plus 7, and I'd be left with, in the second term, minus 7. Hey, guess what we get? That's exactly what I thought the derivative was going to be. All right, so it works. Is that all right? You want to ask a question?
Why is it x plus 7 minus 7?
Because when you factor out, when you factor out x plus 7 to the 10th, what are you left with? You're left with an x plus 7 to the first, and then this is minus 7 x plus 7 to the 10th. If you don't believe me, distribute this back in, right? What do you get when you have x plus 7 to the 10th times x plus 7th? X plus 7? Okay. Minus x plus 7 to the 10th times negative 7, or times 7, minus 7 times x plus 7 to the 10th. Okay? So I factored it out going this way. If you distribute it back in, you can see how it works. Is that all right?
Yeah.
Okay. Oh, and what was the derivative of c all along? 0. Okay. All right, good. Try another one. Do you want to ask a question? Is that strategy like easy, medium, or hard? Like more practice and you'll get 10 right, no problem? Okay, good. All right, let's do okay. So here it is. I have something, it's a quotient. I don't like quotients, so maybe I'll rewrite it. To the negative 1/2. But rewriting it as a product doesn't help me because one has to be the quotient of, one has to be the chain of the other, and there's no way that x is going to be the derivative of negative 2x. They're the same degree, so I'm stuck. And it's number 10 on the gateway. Okay, so I look at the pieces that I have and I take the most complicated piece and I set the inner function equal to u. So in this case, u is going to be 5 minus 2x. Alright, if u is equal to 5 minus 2x, I need to find out what x is equal to. Let's see. U minus 5 equals negative 2x. X equals 5/2 minus u over 2. Or u minus 5 divided by negative 2. Same thing. Are people okay with the algebra that I did? I just solved this problem for x, and I got x equals 5/2 minus u over 2. Tell, is that all right?
Yeah.
You sure? All right. The other piece I need is I need to know what u prime is equal to. Negative 2. I'm going to write it in Leibniz notation. Du dx equals negative 2. So du equals negative 2 dx, or dx equals negative 1/2 times du. Alright, I think I know what u is, I know what x is, and I know what dx is. I think I have all my things to plug in now. Actually, this is, yeah, no, that's great. Okay. Alright, we ready? Alright. Instead of x, I write instead of 5 minus 2x, I write
U.
Instead of dx, I write,
What about du?
I'm going to say negative 1/2 du. Alright, it's a little messy, but I think all I need to do is oh, didn't get that. Okay. I think I just need to multiply. What do you want to do? You want to multiply the negative 1/2 in, or the u to the negative 1/2 first, or both at the same time? How's your algebra feeling? Okay, I'm not. Zach's like whispering. No one's saying anything. Alright, fine. So I get 5/2 u to the negative 1/2 minus, what do you do when you multiply? Add the exponent. So this is u to the first. U to the first minus 1/2. Alright. Yeah. Right? Isn't that what we're doing?
Yeah.
Okay. U to the 1/2 over 2. But then I have to multiply all that by negative 1/2. So I have to distribute again. You ready? Negative 5/4 u to the negative 1/2 minus, plus 1/4 u to the positive 1/2 du. Oh, come on. I could have given this one algebra 2-student. Maybe. But they could have done everything inside. And that small switch allowed us to distribute and figure things out. And now I can take the antiderivative. All right, so u to the negative 1/2. All right, so increase the exponent by 1/2. By 1, sorry. And now divide by the new exponent. So what's that? What's negative 5/4 divided by 1/2?
No, it'd be negative 10/4.
It's negative 10/4.
So dividing by 1/2 is the same as multiplying by 2? Okay, negative 10/4. Okay, I'm with Gabby and Asa on that. And then u to the 3/2. And what's going to be the exponent out in front?
2/12 or 1/6.
Because dividing by...
Divide by 3/2, you're multiplying by 2/3.
Okay, good. And then don't forget. And then Gabby will say, but that's not the answer.
You have to put in negative 10 times 5 minus 0x to the 1.
Okay. 5 minus 2x to the 1/2 plus 1/6. 5 minus 2x to the 3/2 plus c. And that's your answer. I agree. So this is a lot more work than just like 1 or 2 steps recognizing the chain rule or something like that, right? Right? Right. Okay. But it's going to be number 10, so you're going to get it right. Right?
Mm-hmm.
No? It's a little too early to tell. But can some of you know you're going to get it right already? Who's going to get it right? Do you know you're going to get it right?
I mean,
Number 1 maybe. Like the first one.
I probably
All right, but that's because it was the first one we did. Like, if I gave you this one the first time, would you have done it? You would have like cried. Should I give you the harder one first, and then they get easier, and you'd be like, oh, this is a piece of cake.
no, I mean, if you start with easy, people have a better approach towards it.
All right. So this is a little bit complicated because of 2 things. First of all, the exponent's to a fraction, and du is not equal to dx. Du is equal to a fraction. In this case, du equals negative 2 dx, so we had to substitute that in.
This would be fine because I would have a
But you wouldn't.
I know. Oh, right, I'm not.
Yeah, it's a bummer.
I'm thinking of a real test.
On your homework. Yeah, on a real test you would, right?
Yeah.
Okay.
I'm going to die if I have to multiply
What?
fractions.
After... Oh, we have applications.
How many concepts of calculus have we done so far? Because I only like 3.
We've done derivatives. We've done integrals.
Okay, so what's left?
There are a bunch of other little things. We're not going to do sequences of series, which is another aspect of it. We're going to do differential equations, which ties together derivatives and integrals. And maybe I should say this. We've done derivatives, definite integrals, and indefinite integrals, which are antiderivatives. And antiderivatives tie the 2 things together.
And after you're done studying calculus, are you free to roam in the math land?
I really don't think it's right.
Calculus opens up the doors to Rome. There's tons to learn, but yeah, to explore. But there's still some things that they might say you should learn. There still might be a sequence to how you learn. Like they might say you should learn linear algebra before you do game theory or something like that. Yes, but there's a lot of other branches. But once you've had calculus, it opens up a little bit. All right, all right, what's 72? All right. Well, I gave you an easy and a hard one. Like, I'm fine doing that. Like, I think you have, 6 homework problems tonight, and I think they're all like this.
Like this?
Uh-huh. Not so, we've done 2, and they're probably... I think there are 6, aren't there 6? Yeah.